Hello, this is Kedulytics and welcome to today's session. In today's brief video, we are going to look at logistic regression. Now, so far in our videos, we spoke about linear regression. And so if you've not watched those videos where we run linear regression models, you may want to check through the channel and educate yourself about those models. But basically, the difference between the linear regression and then the logistic regression models has to do with the outcome variable of interest. So while the linear regression uses a continuous or quantitative variable as the outcome variable, the logistic regression uses a categorical outcome or variable as the outcome variable. And that variable should have a dichotomous categories, such as yes or no, present or absent, or two categories where we will code it as 1 and 0, where 1 will be our interest, a category of interest for which we are trying to do our prediction on. So if you watch this video right to the very end, we are going to explore how we can use the logistic regression model in a practical way, especially in the health or clinical setting. So we have a dummy data set which we are going to use for the purpose of this video. And we are trying to predict or model or develop a logistic model such that our outcome variable will be nephropathy, that is having kidney problem. And we are going to see how variables such as age, sex, educational status, alcohol intake, and smoking have on nephropathy. So basically that is our aim. And we want to translate that objective or aim into lines of code statistically, so as we can be able to see how we can use statistical methods to be able to solve that problem. Now, basically, to run a logistic model in STATA, you type logistic, and then the next that follows should be your outcome variable or your dependent variable or your variable of interest. And then you have your independent variables follow, or your exposure variables or predictor variables. These are synonymous words that we can use interchangeably. So we mentioned age, we mentioned sex, we mentioned educational status, alcohol intake, and smoking status. So we add I dots to this, I dots to this, I dots to this, and then I dots. So these I dots we're adding is just to tell STATA that what we are working with is our categorical variables. And so you should use the first category as the reference and give us the output. And we want to add the base level so that we can be able to see the category that it uses as the reference. So we add base level to it. And this would give us odds ratio and the corresponding 95% confidence intervals and the p-value associated with them. And so we run this code and we wait a while for STATA to do its thing and generate results. So yes, so we have our results here generated. So we look at the output. So it gives us the code. So logistic, nephropathy, which is the outcome, each categorical or continuous variable, and then the rest follows. These are the predictor variables. And then we added base level so as to be able to identify the reference group. So this is the reference. So the reference are tagged as 1. Now let's try to have a meaning to what we have. So this is the logistic regression. It's run it on a number of variables. There are 328 variables that it's observations that it's run it on. And this is the chi value and the probability. The probability value here, the p-value, is statistically significant. So it means the model does well. And we can rely on its predictions of nephropathy. So now we try to interpret the odds ratios that are given. So these are the odds ratios. And then we have the significant levels, which is the p-value, and then the confidence interval. So scrolling through the p-values, we realize that it is only smoking status that has a significant p-value. All the rest are not statistically significant. So we will not make any conclusions about whatever odds ratio we are getting. Simply means they have happened by chance, or the chance element of those things happening is so high. This, for example, is 63.9%, which is very high. This is 85.3%. So the chance element is quite high, and so we can rely on it. However, this is what 1%. This is 0.1% actually, which is quite low, and so we can rely on these values that it is giving. So now let's try to explain what the odds ratio are. Now, notice for continuous variables like age, the interpretation seems to be a little different from the categorical outcomes. So now for age, we'll say for every unit increase in age, there's a corresponding 1.005 increase in the likelihood of what? Getting nephropathy. So now when we go to the sex, we have male and female, and male is the reference group. So to interpret this odds ratio here, it means that there is a 7.37% increase odds of getting nephropathy among females compared to males. Now, when we come to educational status, you can see that they are all less than 1. And so there's reduced odds of getting nephropathy among these categories compared to those without. So usually we subtract this value from 1, and this should give you something close to 0.149 something or 41 something when you subtract this from 1. So what it means is that those with primary level of education have a 14.1% reduced odds of nephropathy compared to those without any form of education. And when we go to secondary level of education, we subtract this from 1, and that should give us something close to 0.333 thereabouts. Yeah, so we subtract, we get 0.33 thereabouts. So it means that there's a 33% reduced odds of getting nephropathy among those with secondary level of education compared to those without education. You can do that for tertiary level for yourself. Now, when it gets to the alcohol intake, here we can see that those who take alcohol have about, when we subtract this from 1, we get 27 point something, 0.3 thereabouts. So what it means is that there is a 27.3% reduced odds of getting nephropathy when one takes alcohol compared to those who do not take alcohol. So in effect, what it's trying to say is that this alcohol intake may be protective in developing nephropathy. So usually, when the odds ratio is less than 1, it means that there's a reduced odds of getting the disease in that category. And it could also be interpreted in some angles to mean that it is protective. Now, when it comes to the smoking status, we realize that those who smoke have about 8.4 times increased odds of having nephropathy compared to those who do not smoke. And this is statistically significant. So somebody who smokes is about 8 times likely to get, or has the 8 times increased odds of getting nephropathy compared to those who do not smoke. So it tells you how dangerous smoking is in terms of statistical analysis here. And so it has to be taken very seriously. So basically, this is how you can be able to run a logistic regression analysis in STATA, and also be able to make meaning out of the odds ratios that are given. Now, if you want to change the base level or the reference group, so for example, if we want to change the reference of from male to female. Let's see, we just change the code to B2. And when we run it, we realize that now females are 1 and then males are now not the reference. So basically, this is how you can twerk around to change the categories if you wish. If you like content such as this, we encourage you to subscribe to the channel. We encourage you to like the video and share. Until we meet again on our next one, this is Schedulytics, and it's a bye.